Alright, please bear in mind that the gas window occur in the post-maturity of all window is starting from the hundreds to 200s in catalysis process. So meaning that as we going deeper at the greater depth, right, the source of oil from sapropelic and humic eventually will convert it into a dry thermogenic gas, okay, methane, right, and wet thermogenic gas. Okay, you can see here from this diagram, right, both methane and wet gas from corrosion type 1 and 2, which is from subpropylene source, is actually produce more volume, right, than the humic source type 3. Okay, why? It's simple, because type 1 and type 2 generates gas during and after the generations of oil in a greater amount than the type 3 and type 4. Okay, most of the wet thermogenic gas here is formed mainly in the upper part of the temperature range between 80 to 150 degree centigrade. Okay, this is called wet gas window that is still occur in all window, which means you can see here the peak for both sources it's at 120 degree centigrade. Okay, so wet gas here refers to component with C2 until C7, and at this time this type of hydrocarbon gas is formed both from the cracking of a sapropelic corrosion, okay, primary cracking, and the cracking of oil by the secondary cracking. So small amounts of wet gas also may form from the humic source as well, okay, such as a coal, but this volume of gas is actually depending on its hydrogen content. You can see here that the wet gas here, it stops to generate and expel windy or window. Okay, all window here is actually 60 to 160 degrees centigrade. Okay. Okay, meanwhile for the thermogenic gas here, methane, right, it also form from all the corrosions type in the high temperature range from around 150 to 200 degrees centigrade. So this is called thermogenic methane gas window. Okay, with the peak it's at 150 degrees centigrade. So you can see here that subpropylic organic matter, right, source is actually yielding 2 or 3 times as much methane as the humic organic matter. Okay, the reason is the same. Type 1 and type 2 corrosions, it generates gas during and after the generations of oil in a greater amount than do the types 3 and type 4. And plus, any subpropylic source oil that is buried deeper is actually eventually will converted to gas. Alright. Next, for the non-hydrocarbon gas, carbon dioxide, nitrogens, and hydrogen sulfide, okay, it seems to be dominantly produced from the humic source during all window in catalysis stage. With you can see here the carbon dioxide organic source begin to increase as temperature exceeds more than 50 degrees centigrade, and the peak occur at 100 degrees centigrade for both source. Tell me, why does humic source has capability to generate more non-hydrocarbon gas compared to sapropylic source? Okay, simple. Okay, because carbon dioxide is mostly available from continental as humic, and humic are sourced from the terrestrial higher plants and coal. Okay, but there is also still carbon dioxide that can come from inorganic sources, but only formed at much higher temperature because they are formed by the functions of or controlled by the temperature, mineralogy, and pore fluid composition. For example, some of the carbon dioxide can come from the chemical and thermal thermal decompositions of carbonates, while some hydrogen sulfide can form by the thermochemical sulfate reductions of the evaporites. Okay, right. So it goes to the same. Same goes to the nitrogen gas, as they are more prone, okay, from the humic source, because many of the living organism in continental contains amino acid and protein compared to the marine and lacustrine source. Okay. Next, we also have the hydrogen sulfide, which generally found at depth beyond 3000 meter. And as you can see here, hydrogen sulfide is more coming from corrosion type 1 and 2, because it is the results of, or the results from the early diagenetic influence of higher sulfate content in marine water type 2. Okay, so if you can see here, there is no show of carbon dioxide and hydrogen sulfides, okay, in the diagenesis stage. Okay. Because you can see here, at this stage, there are very little of this compound that is survived due to early microbial and chemical reactions. Okay, remember, dry bacteria gas form by the reductions of carbon dioxide at the surface sediments, and there is also sulfate reduction process that actually eliminates all the sulfur content during diagenesis. Alright, next we continue with the source of natural gas from the coal. Okay, so methane also has been found as the major hydrocarbon gas that released from the maturations or qualifications of humic coal. So the potentials of petroleum expelled from coal is still remains in debate. Okay, because of the coal behavior itself, in which the oil generated from this biogenic source or bedded coals, okay, tends to be absorbed in the fine pores of the coals, and eventually this trapped oil is later will be converted to gas as the coal matures under increasing thermal stress. So meaning that coal has the characteristic of absorbing, okay, the oil in their pores. So after a while, when there's an increase of temperature, right, this existing oil that is actually trapped in the pore, it will start to cook again, okay, until it's cracked by the secondary cracking and expel, okay, or generates gas. Okay, all right. In the coal itself, there are also small amounts of heavier gases such as methane, butane, that are formed also during coal maturations. Okay. However, they are strongly absorbed. Okay, they are strongly being absorbed, so therefore their presence are only calculated as estimation and prediction. Okay, so sorry. So 1/3 of the gases that are actually has coming directly from coal by the primary cracking. Okay, meanwhile 2/3, okay, of the gas usually come from the secondary cracking of the oil generated by coal itself. Okay. Right, so this figure shows the stages of coal formation in which the classifications of coal is according to their degree of metamorphisms or qualification in the natural series from lignite to anthracite. So as we going deeper in depth, the formation condition is depend on the temperature, pressure, and the presence of carbon that is preserved in the coal, which temperature will be increased as well as the pressure, whereas the H by C, O by C will be decreased, and also moisture will be decreased. So initially, coal is actually formed by the peat that originated from roots or bark of tree, okay, by bacteria and chemical change. So peat is actually a partially decayed plant matter in swamps and bogs that has a low heat content. So as we go in deeper at a greater depth, right, coal rank change. Okay, we'll change from the peat that is not a coal yet, lignite or brown coal, right, and then bituminous coal, soft coal, and lastly is anthracite. Okay, that is hard coal. So lignite here uh, is contains a low heat content, right, and low sulfur content, and it is also limited supplies in most of the areas. Okay. Meanwhile, bituminous coal here is has been extensively used, right, as a fuel because it contains high heat content, and it has also large supplies from most of the areas. Okay, so basically methane forms from the bituminous coal has the highest amount uh, that is generated at temperature 80 degrees, okay, under the low volatile bituminous. Okay, and then we do have anthracite as the highly desirable fuel because of its high heat content and low sulfur content. But the supply is very limited in most of the area. Uh, from the anthracite also, we do found the carbon dioxide, okay, that is dominant in the medium volatile to anthracite and moderate and has been found in moderate amount in the crude oil. Okay, so the other source of natural gas is actually also coming from the condensate. So condensate here refers to the main forms of petroleum in which it is a gas state in reservoir and condensed to form liquid at the surface. So condensate may have several modes of origin, such as the first one is by the intermediate product between oil and gas, right, during the thermal decompositions of oil in the reservoir. And then by the evaporation fractionation. It is the process of conversions of oil to gas in a reservoir. And to be specific, this process will form a fractionation between aromatics and saturates oil to gas in reservoir. Okay. And lastly, it's actually originated also by the gas or from the gas stripping process in the vertical migration, in which this process occur from the gas phase migrations of hydrocarbons out of an oil pool because of physical phenomena such as vaporizations or gas stripping through faults, fractures, and other permeable pathway. Okay. And last but not least, the hydrocarbon gas, this non-hydrocarbon gas, okay, is we do have carbon dioxide, hydrogen sulfides, okay. So for the carbon dioxide, okay, it's originated from the thermal decompositions of organic matter in corrosion in and above of the oil window starts from during diagenesis until catalgenesis. And it also originated from the chemical reactions of kaolinites and carbonates at temperature more than 100 degrees centigrade. So kaolinites and carbonates, when it's decomposed, right, it will form chlorides and carbon dioxides. Okay. Carbon dioxide also can come from the volcanic activity towards carbonate. Okay, that is occur when there are high temperature of magma that penetrates the carbonate rocks, and then carbonate decompose and giving off the carbon dioxide, and later migrates and trap into the reservoir by nearby structure. Okay, hydrogen sulfide is the deadliest gas, and it was produced in large quantities in nature, which if 0.1% concentrations found in the air, it can cause respiratory paralysis and fatal. Okay, it's come from these origins of thermal decompositions of high sulfur oils at deeper than the oil window, and then thermochemical